Hello, Yawning Angel back again with another AMOS video, and in this video we're going to be taking this program and turning it into this. Yes, we're going to be looking at shooting things in AMOS, how to get our little spaceship on the screen to shoot some asteroids. This is going to be quite exciting. Now I have to say, in AMOS, shooting mechanics, there's a couple of ways of doing it. There's a mathematical way, which is a more precise way for more complex shooting algorithms, or there's the way I'm going to show you now, and that's just by simply using Bob collision detection. So yes, we're going to be using Bob collision detection to work out our shooting algorithm, as it were. When you think about it, the missile that we fire from our ship, or the bullet, is a Bob, and the asteroid on which it's going to hit is also a Bob. So we can use Bob collision detection to work out if a hit has been made, and this will help us facilitate our shooting mechanics in the game. I've covered Bob collision detection already. That was on a video which you can link to up here, so I won't be going into the mechanics of that in any great detail in this video. But this is a lot of fun and quite an easy way to get a very simple shooter up and running in no time at all. Before I get going, I just want to give a very quick shout out to Mastodon user Alanon, who gave me a couple of pointers in this direction and got me up and running. So Alanon, thank you ever so much for that. Right, with all that said, what I'm going to do next is take you through the base program and show you the mechanics of that and what that is doing currently. I'm then going to show you the Bobs that I'm using for this program, and then, and you know how this works, we're going to grab a cup of tea and dive on into the code, and we're going to upgrade the program, and we're going to upgrade our spaceship and give it a gun and enable it to shoot things in its path. How exciting is that? This is the code for this program as it stands. So let's just do a quick run through and show you what this does so far. So we've got a ship which just flies around the screen under control of the joystick. There is no collision detection in here whatsoever. So this is the bare bones version of the program. So let me stop that and let me take you through the code. So starting then, we open screen 1, we set that up, we then load in the Bob image bank, so there'll be a bit about that after this bit of video. We then get the Bob palette, we extract our colors, we extract all those values out into an array. See my previous video for how all that works. We then set our default palette based on the palette from the Bobs. We clear our screen, we switch on our double buffer, we set our mask, we assign our first Bob. Bob 0 is our spaceship image from the image bank, so that would be the first Bob. I've covered all this before in previous videos, links in the description down below for those. So I'm not going to go into any great depth explaining these here. Bit of a reference there as to what the Bobs are. I need to double check that. We will come to that in a moment. We've then got a procedure which will place all the asteroids on the screen. I'll show you that in a while. We set some global variables, and then what I've got here is just some placeholders, because this is where we're going to insert the code which gives us our bullet control, our collision detection, and all the rest of it. But if we just ignore those for now, we've just got some very basic procedures in here. So we've got a main loop procedure which sets up our screen, sets some variables, sets a score counter, positions our ship, and at the moment all this is doing is just controlling the ship, or enabling us to control the ship via the joystick. So what we're going to do in here, we're going to do a lot of stuff like handling the bullets, check for collisions, and all the rest of it. But this is it at the moment. We've just got our basic Bob is now set and positioned on the screen. We've got our wait VBL command in here. Once again, this is where we're going to put in the checking for hit detections, determining which Bob has been hit, changing the graphics as well. We're going to add all that in. If I go down here, so this is our automatic movement of the ship. So the ship moves vertically up the screen automatically. We can speed it up, slow it down, but we cannot stop it. And we've got a little bit of animation in there for the spaceship. Normally you'd use something in AML to do that, but this is quick and dirty code, so we're just doing a bit of a hack there to swap between two images. When the ship gets to the top of the screen, we reposition it down to the bottom. And then we've got our joystick control in here, checking for joystick left, joystick right, joystick up will increase the speed of the ship. We've got a fire button here, which at the moment is doing nothing, but this will instigate our bullet or our missile being fired from the ship. Then we're going to put in a procedure to check for collision between bullet and asteroid, another procedure to check for the collision between the spaceship and an asteroid, a procedure to check which bob has been hit. Yes, exciting stuff. A procedure to update the bullet and control it on the screen. So is it active? Move it. If it falls outside the screen, deactivate it. We're going to do all of that. There will be a procedure for handling the shooting of the bullet. And then this is our procedure here that sets all our targets up on the screen. So this loads the screen with asteroids. Really not going to go into this in any great detail. All we're effectively doing is setting a random value for a random number of asteroids to appear on the screen. We need at least 5 on there. And then we set random X and Y coordinates for each one of those asteroid bobs. And a bob is then placed at random positions around the screen. It has its own numeric value, so we know which bob it is when we do the collision detection. I'll go into that in a bit more detail later on. And finally, we're going to put a procedure in which to define what happens when it is game over, when you have crashed your ship into an asteroid and no longer have a ship to play with. Right, and that is a very quick whistle-stop tour through the code. Right, so here is the ABK file that holds our bobs. So let's just go in there quickly and take a very, very quick look at what we've got. So we've got a bob for the ship. We've got a second bob that gives us a bit of animation for the ship. Our third one is the asteroid. Our fourth bob is the bullet or missile which is fired from the ship, and this is what we will be using to check for collision detection against the asteroids. And we've also got here a exploded asteroid, and we've got an exploded ship as well. So in total then we have 6 bobs making up the image bank for this program. Right, here we are in the code. First off though, quick mouthful of tea. Oh, that's good. Yep, first cup of tea of the day, and it's all good. Using the RMC Cave Dwellers mug this morning. Right, okay, so we've got a lot to do here, so let's get on with it. So I've dived straight into the code here. We've got some variables we need to define in order to get the mechanics of our shooting up and running. So, on top of the variables that are already in here, I'm going to add some extra variables in. So this first variable going in is called TGT count hash. This is a variable which keeps track of the number of asteroids that we would have shot with our spaceship. We now need some collision specific variables. So all of these will be explained in more detail as we start to use them, but I just need to define them up here. I also need these to be global because this is quick and dirty code. We just need things to work today. Right, so I've got hit bob x, hit underscore bob y hash. That's for my collision detection. So those are, if I remember correctly, are used to detect the X and Y coordinates of the bob which has been hit. Right, bullets, specific variables. Right, I've got bullet underscore X, bullet underscore Y, but you can't guess what those are. I've got bullet underscore active and bullet underscore speed. So this is really variables to control our bullet, our X and Y coordinates of the bullet, whether our bullet is active or not, and our bullet speed. Okay, so initializing some variables here. I've already initialized BB number is 1, so that's the first bob for our spaceship image. So I'm now going to do hit bob x hash equals 0, hit bob y hash equals 0. That's those done. Now what I need to do is bullets x equals x underscore pos. So what is happening here is the initial position of our bullet is going to be the same as our spaceship, which kind of makes sense because we want our bullet to come from the spaceship, don't we? I then need to set bullet active to be false because the bullet is not active when we start the game. And I need bullet speed to equal 10. Just an arbitrary value. It's the animation speed of the bullet. And I need tgt underscore count hash to equal 0. So we haven't actually hit anything. Right, let's just quickly tidy up some code. Let's go down here and quickly remove that. Right, so then we start the main program and we go into the main loop and we've done all the stuff there. So the first thing to do is to handle any active bullet on the screen. And to do this, I'm going to call a procedure called bullet update. So with bullet update, that will deal with any administration that needs to be done on the bullet, and we'll get to that in a moment. We then need to render the bullet if it is running. So if bullet active, remember we set bullet active to false, so nothing's going to happen the first time through, but then what we want to do is set bob 2 to be the positioning for bullet x comma bullet y, and the bob that is coming from the image bank is bob number 4. We know all about this. We know about taking bobs. This value here is what's coming out of the ABK file, and this is the value which we set that bob to in this program. We've covered all this before in previous videos. Right, now we need to check for a bob collision. So has the ship hit an asteroid? So we're going to make a procedure called ship hits detect. You need to be very careful when saying that, especially if drunk. We're then going to, that will pass a parameter back to tell us whether the ship has hit a bob or not on the screen, so whether it's hit an asteroid. So we will check the value of param hash, that equals -1. We will then jump into a game over routine. We'll then end that. Remember, with procedures, you can pass back a param value. Once we get into this actual procedure, you'll see why we're passing back -1 if it has been hit. Right, so that's our game over routine. We now need to, right, so the spaceship is positioned. We do our wait VBL. Now we just check for a generic bob collision. So this will be for the bullet. Has the bullet hit anything? So we will just do a very simple procedure called hit detect, and that will do that. So if a hit has been detected, so here we're going to do a if param equals -1 again. Then what we're going to do, we're going to play a sound, boom, big bada boom. Then we need to determine which bob has actually been hit, because there'll be different asteroids on the screen, and we need the program to identify which asteroid the bullet has hit, okay? Because once it's identified that, it needs to remove that bob from the screen and put another graphic on, increment counters, and do all this sorts of stuff like that. So what we're going to do is we're going to do another procedure which will just be called hit bob. That will determine which bob the missile has hit. We're then going to remove the bob that was hit from the screen, and we'll do this by using the bob off command, and whatever value is returned back from the hit bob procedure, that will be stored in param hash, and that's the bob we will switch off on the screen. We then need to place the exploded asteroid bob on the screen. So for this, we'll use bob3 and we'll do hit bob x hash, comma, hit bob y hash, and it will be the 5th bob from the ABK file, which we're going to load into bob3. That will be the bob which is displayed on the screen. Hit bob x and hit bob underscore y are the coordinates of the bob that was hit, which we've already determined in the hit bob procedure. Yeah, okay, keeping up? Good. We now need to keep a track of how many asteroids have been hit, so we'll just increment a counter equals hits counter +1. I know there's another way of doing that. That's the way I choose to do it though. We need to increment a score counter. So no, I've done the wrong thing. Wrong, that doesn't need to be there. Yawning Angel. This needs to be target count hash equal target count hash +1. This is keeping track of the number of asteroids hit within the game, and this is separate from a score counter, and you will see why later. Hits counter +1. Okay, and then we're just going to dump in a very simple locate 0, 0, print score, and that will be hits underscore counter. Okay. Once all that's done, we're going to remove the explosion bob, because we just want the explosion to appear for a little while on the screen. And by happy coincidence, running this piece of code gives us enough time for the explosion to appear, and then we can just remove it again. So we know that that explosion is, place the exploded asteroid here, is bob3. So what I need to do down here is just turn off bob off 3. That's all we do it. That's all we do, just to get rid of that. Dead straightforward. As part of this game mechanic, what's happening is once we've cleared all the asteroids from the screen, we're going to reset the counter and repopulate. Because why wouldn't you? You just want the game to keep going, yeah? And this also gives us some future proofing for another version of this program, which I am working on currently. Not for this video, though. Right, so what I need to know is check. So if tgt underscore count equals t hash, so that's that. So t hash is when we populate the screen. This is the variable which holds the number of asteroids which are going to be on the screen. So if that is, say for instance 5, and we've actually shot 5, so tgt count is keeping a track of that. So if those two equal, what we want to do is then set tgt count hash to 0, Yawning Angel, no, equals 0. We'll get there eventually. I'm trying to multitask. We set that to 0, and then what we do is reset our position of our spaceship, and then we repopulate the screen with more asteroids. So what we need to do here then is set x underscore pos to 160 and y underscore pos, line that up, to, where does that got to go? 150. 150. That will reposition the spaceship, and then we need to run the procedure target placement endif. And you're probably wondering, why, Yawning Angel, are you not pressing F3 to realign everything? I can't, because I haven't defined some of these procedures yet, and AMOS will not be happy. But I think that's about it. So then the usual code in here. So this is the spaceship, just moves automatically up the screen. We're toggling the animation, we're controlling our joystick, and the only other thing we've got to add in here is if somebody presses the fire button, what we want to do is call the procedure bullet shoot, because that will handle the animation of the bullet and the whole thing leaving the ship, and everything will start to look pretty cool. Right, so the next thing we're going to do then is grab another mouthful of tea, and then we're going to write the other procedures which we've just referenced and get some mechanics working. So let's do that next. More tea. I must say I'm wolfing my way through that cup of tea quite quickly today. So, right, okay, let's get on and make some of these procedures which are going to give us the guts of the functionality. So the first procedure we're going to do is a procedure to check for the collision between a bullet and an asteroid. So this is going to be called hit detect, okay? And basically what we're doing, we're going to set a value called h hash, and we'll just do the simple Bob collision detection command. Bob col 2, so has Bob number 2, has that hit any Bobs between Bob 4 and, wait for it, let me just type this and then I will explain it, t hash plus 4. And end proc return h hash. Okay, what is happening here, Yawning Angel? Okay, so this is what is going on. What's happening, we're going to check that has Bob 2, which is the bullet, has that hit a Bob from Bob number 4 to the range of the asteroids. Now the asteroids, the number of asteroids we have is stored in t hash, but I'm incrementing that number by 4 because we have 4 other Bobs in play before we get to the asteroids. Yeah, so the asteroids will appear, in effect, if you had to look into memory, what the asteroids will appear from position 4 onwards for our Bobs referenced in this program. A little bit confusing. Get your head around it, just read through the code, you'll get there, but it makes sense. This is absolutely working. So what happens then is that is then going to give us a number of the Bob which was then hit, and that returns that value in h hash back to the main loop where it will be actioned. Now, in a similar vein, what we're going to do is do a collision detection for the ship. So we are calling that procedure ship hit detect. Okay. The first thing we'll do, we'll just initialize h hash to 0, and then we're going to do exactly the same line of code. H hash equals, and then what we're going to do is Bob col. So the ship will be in Bob position 0, and it needs to, has it hit an asteroid, so it'll be from position 4 to t hash plus 4 to there, and proc, and we will return h hash. Now you're probably looking at this code and thinking, this seems very simple, but also very complex, Yawning Angel. What is going on here? So these two procedures are quite the same. Now you could have one procedure that does this, and you can pass in the Bob that you want to check against. So instead of it, we're hard coding here, check for Bob 2, and down here we're hard coding check for Bob 0. We could pass in 2 or 0, but I've separated these out because it gives you a bit of leeway, a bit of flexibility, because you might want to do something different with asteroid detection, you might want to do something different with ship detection. So while the core guts of it are the same, I've separated them into two procedures. You can do as you wish, but you know, your mileage may vary on this, so see what you feel comfortable with. But once again, we're checking the ship here. So Bob 0, which is our spaceship, has that hit anything from Bob 4 to the end of the range of the asteroids? So if we've got 10 asteroids, has it hit a Bob from 4 to 14 in effect? Okay, so that'll be the 10, which will be stored in t hash plus the 4. Okay, right, next up, we need to check to see which Bob was hit. So now we write a procedure hit Bob. Now I'm not very imaginative when it comes to procedure names, so that's why they're all a bit similar. Anyway, so the first thing we're going to do is we're going to loop through all the asteroid Bobs and see which one was hit. Okay, so let's just dump some code in there. So loop through all asteroid Bobs to see which one was hit. Okay, so what we need to do here is add 4 on as we have asteroids from Bob position 4 onwards. Okay, so you're going to see this come up quite a bit in this program. So let's go there. So we've got a variable called TB hash, and that is going to equal the number of asteroids that were allocated at the start of the program plus 4. Okay. Then we're going to do a for loop. So we will do for, and we will do b equals 4 to TB hash, because we're starting at 4. Okay. So 4 to the end of the asteroids that were done. Then we need to check for if one matches. So if we've got a collision with the asteroid that we're checking. So it's effectively that the program is going to each asteroid on the screen and going, have you been hit? No. Have you been hit? No. Have you been hit? Ah, yes, you've been hit. Right, okay, so if we've got a collision, what we need to do then is get the coordinates of the asteroid which has been hit, okay? And to do this, here's our hitBob variables coming in. So hitBob underscore x hash equals, now here's the command, x bob, and then the number of the bob which we're checking. So we've got an xbob command will return the x coordinates of the bob that you tell it to check against. Similarly, we're going to do the same for y. So hitBob underscore y hash equals y bob, and we tell it which bob to check. So what's happened here, the program has gone to each bob, have you been hit, have you been hit, then it finds one, have you been hit? Yes, you have. There is a collision there. We've got a collision. So now I'm going to get the x and y coordinates using x bob and y bob on that particular bob that has been hit. There's lots of bobs here, but stick with it, okay? So then what we need to do is set the value for return and exit this proc. Then what we would do is set bb hash will equal b, and then we'll just exit, because we've got, we've detected a hit. We don't need to do anything else now. We can just leave straight away, because for this program, we can only hit one asteroid at a time. In other programs, you may hit multiples, and then you might want to do something a little bit more creative with this. But for now, we've just detected a hit, and now we are out of here. End if, and we end proc, and also we need to pass back bb hash. Yawning Angel, why have you stored the value of b in bb hash? Why could you not just have returned b? I could have returned b, but by moving the value out into another value which we're going to pass back, just gives that level of separation. So if I wanted to do anything else to the value b in the program, I could, or I could do something else to the value of bb hash if I wanted to, without affecting the one which it references. Does that make sense? I'm all for this levels of separation within the code. Try not to make use of the same variable over and over again for multiple things, because there will come a time when you'll accidentally use it for something else and it will corrupt its value and corrupt your program. So keep variables separate as much as you can. There you go, top coding tip from Yawning Angel. I'm going to grab some more tea and then we'll carry on. Right, back with fresh tea. Definitely monstering through that tea today. Right, okay, so our next procedure then is going to update the bullet and control it on the screen. So the basic premise here is if the bullet is active, change its Y position by using the bullet speed value. So the bullet is going to go up the screen. And if the bullet falls outside of the screen, deactivate it. Quite straightforward stuff. Basic animation administration here, as it were. Right, so this is a procedure called bullet updates. Okay, bullet update, and proc there. Right, so what we need to do, we only want to do this if the bullet is active. Okay, so if the bullet is active, if the bullet, Yawning Angel, there we go, if the bullet is active, what we need to do is set bullet y equals bullet y minus bullet speed. Y minus Yawning Angel, where it's a Y value which is going vertically up and down the screen, and because we're going up the screen, we're subtracting from the value of bullet Y each time to go up the screen. This is the same as what we're doing for our ship, so nothing out of the ordinary here. We now need to check if bullet, can't spell bullet, if bullet y is greater than 200, or bullet underscore y is less than 0, what we need to do is bullet underscore active equals false, and then we need to turn off the bullet, bob off to end if. Okay, so what that's going to do is check, so has the bullet, is it out of the bounds of the screen on the vertical axis? Is it off the top of the screen or off the bottom of the screen? Unlikely to be off the bottom of the screen in this instance, but this is kind of future-proof in our program. If that's the case, then we just deactivate the bullet and turn off that bob so it vanishes from display. Final end if in there. I will tidy this code up in a minute. I need to get all the procedures written first. Right, now we start to get to the exciting thing. So now what I want to do is have a procedure that controls the shooting of the bullet. Procedure bullet underscore shoot and proc. Right, what's happening in here? So the first thing we want to do is play a sound, and AMOS has some sounds built into it. So we're going to use the shoot sound. Next up is bullet is now active. Bullet is now active because the fire button has been pressed. So bullet active equals true. Let me just quickly sort that out. And now the bullet should start its flight, its journey, its bid for freedom, or its bid for destruction from wherever the ship is placed, okay, because the bullet needs to come from the ship. So bullet should start at the same position as the ship. Yawning Angel, can't type fast this morning. So bullet x equals x underscore pos, and bullet underscore y equals y underscore pos. Okay, so basically wherever the ship is, the ship's x and y coordinates, that will now be assigned to the bullet's x and y coordinates, and we are good to go. So next up, nothing much after that. So we've got this target placement procedure here, and you've already seen what that does. That's quite straightforward. And we've got a game over procedure to write, which is not too hard. Let me just check. Yeah, so the game over procedure is the next one to write. So what I'm going to do now is press F3. Oh, got an undefined procedure. That's true, I haven't written the game over procedures. Let's just dump a procedure in there. So just so AMOS is happy, I'll write the code for this in a minute. Procedure, and that is a game over routine and proc. Okay, so now I can press F3. I'm missing okay, I need to go through and do a little bit of debugging here because I think I'm missing some if statements. So let me do that quickly and then we'll be straight back. Okay, back in the code. I've made a couple of mistakes which I just wanted to highlight. So the first one was here. After your hit detect, you need to be checking param hash. I miskeyed it as param. I left off the hash, so it wasn't detecting the hits. I also missed out a next command in here. So in the hit bob procedure, I missed out this next B. That was causing me some of my end problems. So we should be all right now. So I've hit F2, there are no errors. Right, so now, if I grab my joystick, my new joystick, look at that, Immortal joysticks. Go and check them out. Great joysticks. Not being paid to say anything. Really nice sticks. Good quality from Andrew at Immortal Joysticks. Right, so now if I press F1, so here we go. I've got on my screen, I've got some asteroids there, and it says press a key to start. So now if I now move, look at that. We've got stuff happening. We've got a score counter moving my ship, and I can shoot these. Now you're probably noticing that I'm hitting these asteroids, and even though we've got the code in the program to detect a hit if the ship hits an asteroid, nothing is happening. And the reason for this is because I haven't written the game over procedure yet. So everything else is working. Our hit detection is working a treat. Nothing else is there because I haven't actually written the code for it. But I think we can safely say that's a bit of a success, and that is all working quite nicely. Huzzah! Now let's get that game over procedure written and we can see the final functionality in play. Okay, so I haven't gone through this in any detail. I've just dumped the code in here, but I'll give you a quick fly through what happens here. So in the game over routine, first thing we do is play the explosion noise. We then show our exploded ship Bob, which is number 6 in our ABK file, and we dump that into Bob 0. Bob 0 is historically the ship Bob number within this program. So you see the ship explode. We dump a message onto the screen that says game over, press R to restart, Q to quit. We then just do a quick do loop in here, so we're checking if the user presses R. We clear the screen, we turn off things, we repopulate the screen with asteroids, then we dive into the main loop. Or if they press Q, the program just exits and the program ends, and that is that. So with that in mind, let's grab the joystick again and run the programs. Let's see that happening. So now I can shoot asteroids, but there I've hit one, and as you can see the ship has exploded and I've got my message on the screen. So R to restart. Now everybody, there is a bit of a glitch with this and I need to sort this out. This is not for this program. It doesn't always work correctly. I need to sort out the routine that handles that restart. But you get the idea. This really is just an exercise in crashing into things and shooting things. So what happens if I press now? No, I'm getting no asteroids. There's definitely a problem here. That is for another day to sort that out. But let's just shoot some things in the meantime, prove that all this is working. So I need to tidy up that repopulate procedure. Because what should happen? Oh, and let's go take that one out, and finally we'll take this one. And that's not repopulating either. So I do have a bit of a problem on the repopulation, but you get the idea. The program, the shooting mechanics are actually working. It's just the repopulating I need to sort out. Probably just a variable not being set somewhere. I'm not going to go into that in this program. If you want to have a go at that and fix that, you're more than welcome. Once again, the code is available to download from my website. Right, so have we managed to get a spaceship to shoot a target on the screen and blow it up and increment a score counter? Yes, we have. So from that point of view, I'm calling this a success. Happy days. And that is it for another video. Thank you ever so much for watching. I really hope this has been of some use to you. Don't forget, the source code for this program and the associated ABK file are both available to download for free from my website. Link to that is here. There'll also be a link in the video description down below. If you want to, you can support me on my Ko-fi account. A link for that is up here. Thank you to everyone who has done so far. I really appreciate it. Thank you as well to everyone who leaves some wonderful comments on my videos and some really helpful suggestions as well. I really appreciate that. Thank you one and all. These AMOS videos are proving really popular and people are just showing how much they enjoy them in the comments they leave. Thank you guys and girls. I really appreciate it. Right, so that's it for this video. There's more AMOS videos in the pipeline. I've got some other ideas and some other things I want to explore coming up. So if you like AMOS and Amiga stuff, feel free to subscribe to this channel. But until next time, whatever you do, look after yourselves, take care and keep it retro.